Hello everybody. Today we're going to look at kind of a whole bunch of different sections. 7.8, 7.9. They all talk about how to factor and solve equations still in this trinomial form, that ax squared plus bx plus c, but when the a term isn't a 1. So when the leading term doesn't just say x squared. So it gets a little bit more complicated, only slightly, but I'm actually gonna, make it more simple than the book does by giving you one method that you can use all of the time. And you don't have to worry about, is this a certain type of trinomial? Maybe I'll do this method. Just one method that you'll always use. All right. So the first thing that we're going to look at is that greatest common factor idea again, because that's the first thing you should try and do every time that you're factoring. Regardless of what it looks like, always look for a greatest common factor, because that'll make factoring so much simpler if you can manage to make the item look smaller. And then the next thing is the factor by grouping, and that's that one system that you can always use. Alright, so our first example here, I want to demonstrate the greatest common factor and how simple that can make things. I have 5x squared plus 15x plus 10. Right, so obviously this term right here is not 1, which means I can't just sit here and think, what are some factors of 10 that add up to 15, and I'll be able to make my binomials. It makes it, a little bit more tricky than that. But because I am thinking very, very cleverly, I can say, I see something that all of these terms have in common. They don't all have a variable of x, but their coefficients all have a factor in common. And what is that factor? That factor is a 5. So if I factor out a 5 as my greatest common factor, what that leaves in here is x squared plus 3x plus 2. And everyone sees how that works. See, if I multiply it back, this becomes 5x squared, this becomes 15x, and the 5 to the 2 becomes 10. Okay, so it's still the same equation, it's just represented differently. And now I can factor this in here so much easier. Right? All I need is factors of 2 that add up to 3. And that's simple. We know that's just 2 times 1. And 2 plus 1 is 3. So my 5 is still on the outside, and I can make my two binomials with my x's, and my two factors are going to be a 2 and a 1, both positive. And I factored that way easier than a different method would have brought me about. Okay, so that's how you would do a greatest common factor type situation. And I want you to practice that with this one down here. And I want to just say something before you start it, which is, yes, there is a greatest common factor. And a nice easy way to tell what that might be. Sometimes it's just whatever the leading coefficient is. Right, so why don't you try this one? I'll take a look at what you get in class. And I want to move on to the factor by grouping. Alright, so once you've done that example, and you're ready to come on to these next ones over here and look at factor by grouping, we want to take a look first at 4x squared plus 13x plus 3. Now again, just like what I said before, the first thing you want to do is say, is there a GCF? Is there a greatest common factor? Between all of these numbers, well, they don't have any variables in common because the 3 doesn't have an x. Does 4, 13, and 3 have any common factors? No, they don't. So I can't factor out a greatest common factor. I have to move to factor by grouping. So what we're going to do with this is, instead of just looking for factors of 3 that add up to 13, because good luck with that, we're going to instead be looking at multiplying the a term by the c term, and that gets me 12. 4 times 3 is 12. Factors of 12 that will add up to 13. Alright, so factors of the first term times the last term, 12, that add up to 13. Well, right off the bat, I got 12 times 1, and that's going to add up to 13. So that's awesome. It looks like those are my two factors. So does that mean that I can sit here and I can just say x plus 12, x plus 1? Is that enough? Does that work? Well, if I multiply it out, that's x squared. I get just an x. I get plus 12x. And then I get plus 12. Well, that doesn't look at all like what I was hoping it would look like. So it looks like it's not as simple as just, okay, I found the numbers, let's put them in. Okay? So let's go ahead and scrap this, because that obviously wasn't the way to go. There's a bit more involved with factor by grouping. Okay? So what we're going to have to do here is take those numbers that you found, the 12 and the 1, and we're going to just split the middle term. So 4x squared stays the same, but I want to represent 13x as the combination of 12x and 1x. Okay, so I haven't really done anything to the equation yet, but I purposefully split this center term into two different numbers. Okay? And now what I'm going to do is kind of just deal with half of the equation at a time. I'm going to just look at this part, and I'm going to just look at this part. Just deal with them completely separately. Okay, so over here, if I'm just looking at this binomial, what's the greatest common factor that I can pull out of this? Well, they do both have x's in common. Okay. What about the coefficients, 4 and 12? Yeah, they have a greatest common factor of 4. So it looks like my GCF here is going to be 4x. When I divide 4x out of x squared, I'm left with x. When I divide 4x out of 12x, I'm left with positive 3. And what about these two numbers? Let's go back to the right side here. Do these two numbers have anything in common? Well, they don't both have variables, and the coefficients 1 and 3, they don't look like they have anything in common either. So, nothing. I mean, the best I can do is pull out a common factor of 1. A positive 1. And what do I have when I divide 1 away from x? Well, I have the same thing. And when I divide 1 away from 3, nothing changes. Okay, so this is interesting. And I want everyone to stop for a second and notice. Very, very important to have the same binomial here as I do here. That tells me that I'm doing things perfectly correctly. Alright, so now my next stage is going to be to combine my numbers in a different way. I have 4x that's multiplying this number right here. I also have 1 that's multiplying this number here, which is the same thing as repeated distribution, right? If I say the 4 is going to multiply the x, the 4 is going to multiply the 3, then the 1 is going to multiply the x, and the 1 is going to multiply the 3. I could just write it like this, 4x plus 1 times x plus 3. Because this too means that the 4 is going to multiply the x, and the 4 is going to multiply the 3. And also that the 1 is going to multiply the x, and the 1 is going to multiply the 3. Okay, so now I've manipulated it, and I have it in terms of two different binomials. And this is my factored form. Now I guarantee you that when we multiply this whole thing out again, I will get back to where I started. So let's check it out. The 4 is going to multiply the x, the 4 is going to multiply the 3. What do I get? I get 4x squared, and I get 12x. Then the 1 is going to multiply the x, and the 1 is going to multiply the 3, which gets me plus x and plus 3. Combine like terms, 4x squared plus 13x plus 3. Exactly the same as I had in the beginning. Okay, so that tells me this right here was my factored form. And let's just review exactly what I did here. I took the middle term and I split it up very deliberately into two numbers that multiplied to 12 and added to 1. Once I split it up, I kind of dealt with the left side and the right side separately, taking out a greatest common factor from the left side and a greatest common factor from the right side. After that, I just rewrote it and I had my factored form. So let's do it one more time over here. I'm going to do it, stick with green again. So, from what I did over here, I can say I need to multiply 2 and 7, and I'm looking at negative 14. So factors of negative 14 that I want to add up to become negative 5. Okay, so this doesn't look like it's going to be very easy. Let's take a look at what we got. Negative 14, that means I'm looking at multiplying two numbers, one that's negative, one that's positive. So I could do negative 14 and I could do 1, that would combine, or I could do negative 1 and 14. Either way, when you add them together, you don't get negative 5. I could do 2 and 7, where the negative 2, so that the combination is negative, and when I add them together, I get positive 5, so I'm almost there. So maybe it's just the other way around, 2 and negative 7. If I multiply them, I get negative 14. If I add them, yes, negative 5. Awesome. So those are my two numbers. What's the significance of those two numbers? They don't help me just jump right to the answer, but those are the numbers I'm going to use to split the middle term. I'm going to rewrite this so it says 2x squared, and the minus 7 over here isn't going to change, but the middle numbers, instead of writing negative 5, I'm going to write that there's 2x's and there's negative 7x's. Combined, that says that there's negative 5x's, but I want to split it up first. Alright, so now that I have it split up, I can look at the left side alone, and I can look at the right side alone. So let's go ahead and take a look at what we can do there. What's the greatest common factor between these two numbers? The coefficients are both 2, so that's something, and they both have x's. So my greatest common factor is going to be a 2x. What's left when I divide 2x from 2x squared? Just an x. And when I divide anything by itself, what's left is a 1. Make sure that you are careful about that 2x divided by 2x is a 1, and you don't just forget about it. Now over here, what's my greatest common factor here? Well, they both have a coefficient of negative 7, and it looks like they don't have any variables in common. So they have a negative 7 in common. When I divide negative 7x by negative 7, I'm left with just x. And when I divide anything by itself, I'm left with 1. Now the check. I have the same binomial here as I do here, and that's very important because I have 2x that's multiplying the x and 2x that's multiplying the 1. I also have negative 7 that's multiplying the x and negative 7 that's multiplying the 1, which means I can rewrite it so that it says 2x minus 7 is multiplying x plus 1, because that means the same thing. It means 2x is multiplying x, 2x is multiplying 1, and negative 7 is multiplying x, and negative 7 is multiplying 1. So I can go ahead and double check my work just to make sure that this is indeed my factored form. 2x times x gives me 2x squared, and 2x times 1 gets me 2x. Negative 7 times x gives me negative 7x, and negative 7 times 1 gives me negative 7. Combine like terms, 2x squared minus 5x minus 7. Awesome. So this was, in fact, my factored form. Alrighty, if you need to, as you're doing these two practice problems down at the bottom, re-watch this, go through it step by step. That way, this whole algorithm, this whole process becomes very, very easy and very simple for you, because it's going to make things so easy if we can, get comfortable with this. Okay. Once you're done with these two practice problems and you feel good about this, we're going to try these two on your own. They are not necessarily specific to either the first A example or the B examples. You might have to check and always make sure that you try for the GCF first. That's always a great place to start. Okay, so we'll try all of those. Make sure that you do these two first and become comfortable. Pause it here for a second, and then try these on your own as well. And I will see you guys in class, and we'll check over it.